Welcome to another lesson. In this one, we'll be discussing dynamic analysis on malware, which is the other very important pillar of malware analysis. In dynamic analysis, in contrast to static analysis, we actually run the piece of software that we are aiming to analyze. This has the advantage that we see the actual behavior. We're not trying to interpret the file to understand its behavior. We are seeing exactly what it is. We are less likely to be tripped up by various types of obfuscation, such as packing. On the other hand, there are some disadvantages as compared with static analysis. One is that it takes longer. You have to run the file and then you have to wait to see what it does. And how long can that take? We don't know. It can take forever. It could be sleeping. It could be waiting for some command from a CNC or some other behavior that we don't know about. Additionally, there's the challenge that the results might be system dependent. If you run it on Windows, you'll get one result. If you run it on a Mac, you'll get a different result. And even for a given operating system, it might depend on which software you have, which version, which update, which hardware. It can sometimes detect if you're running it on a virtualization versus bare metal. So there are a lot of challenges when doing dynamic analysis. But nonetheless, it makes up one of the main tools of an analyst. While performing dynamic analysis, there are a lot of things that you can pay attention to. Some of the things that have been found to be most useful for detecting suspicious activity has been process activity, file changes such as copying, editing, writing, encryption, registry key changes, API calls, network activities such as sending packets, receiving packets, communicating with the CNC, memory dumps. If you are performing your dynamic analysis manually, you can also try using a debugger to be able to pause the execution and see what's going on. We're going to demonstrate some of these so you can see how this works. But for us data scientists, the goal is really not to do manual dynamic analysis, except maybe for research purposes, but rather to automate the extraction of this information, featureize it, and then of course create a classifier. To capture the dynamic analysis information, we're going to be using a tool called Process Monitor, or ProcMon for short. It's a free tool. You can easily download it from the link shown. To install it, simply extract the archive that you obtain by downloading, and then it is ready to be run. So I'm going to run it now. And what you see is that it immediately began capturing a bunch of logs. Let's clear that and take a look at the UI. So we can capture registry activity, file system activity, network activity, process and thread activity, and some profiling events. Let's clear the captured information, and now I'm going to run a malware, and let's see what it captures. As you can see, the number of events that it captures increases extremely quickly. It is not only capturing the events for the process that we just ran, but also everything else that's happening at the same time. So an important step in performing this type of dynamic analysis is to filter down to the process that you're interested in. So let's find that process. And once I find it, I'm going to filter down only to events that correspond to this process. As you can see, it's quite many as well. There's a bunch of file operations, files being opened, read, created, written. And by now you can probably guess that it's WannaCry and has been detected by Windows Defender. And we can also find registry key activity. So when you are analyzing samples yourself using dynamic analysis, you can collect all this information and use it to understand what it is that's being run and what it's doing. In the next lesson, we are going to train a dynamic malware classifier. Looking forward to seeing you there.